Hello, I'm Andy Peel from the CCDC. In this tutorial, we will explore different display styles, visualize crystal packing, visualize interactions, measure distances and angles, and produce high-resolution images. We begin by opening Mercury. On the right-hand side, you can see the Structure Navigator, where the currently displayed structure is listed according to its ref code. This is also the place where you can browse different structures or select one by typing in the code. We'll select a structure by typing in the following ref code: BNZ-CTC01. This is a cobalt carbonyl cluster. In order to move the structure around, you can left-click to rotate the structure. If you hold down Ctrl while simultaneously holding down the left-hand mouse button and dragging, that will move the object in the plane. If you right-click and drag the mouse, that will zoom in or zoom out on the current structure. If you hold down Shift and left-click, that will allow you to rotate the structure in the plane of the display only, and Shift and right-clicking will allow you to change the depth Q. The depth Q is set to 0 by default. We will now explore some of the styles that are available in Mercury. The principal style is selected from the Style drop-down menu at the top, or it can also be accessed by right-clicking in the visualizer area and then choosing options from the Style drop-down menu. The options available include Ball and Stick, which is a general display style, Wireframe, which you might find useful for exploring packed structures, and Ellipsoid, which you would typically use for publications. The ellipsoids in this style represent the anisotropic displacement parameters, abbreviated as ADPs. ADPs describe the uncertainty in atomic position caused by atomic motion and disorder. Check the links in the description for further information on the origins of these effects. You might want to explore the crystal packing. To do this, we first enable packing using the packing option from the Display Options toolbar. You might need to zoom in or out to see the unit cell contents, and you can turn on or off the display of the unit cell. To make things clearer, we can also change the style to wireframe. In order to see a larger section of the packed structure, we go to the Calculate menu at the top and select Packing and Slicing. Using this, we can expand the structure along the different directions. There are some preset options for convenience too. You can also view slices of the structure using the slicing options here. That's particularly useful when combined with morphology features that are available from the CSD particle menu. We'll reset the display now. We can easily revert to the ellipsoid style from the Style menu at the top. Another thing you might want to do is explore any intermolecular interactions that might be present in this crystal. We can customize the definition of a hydrogen bond by double-clicking on the H-bond line here. As you can see, it's possible to add not only different donor atoms, but different donor chemical groups. The same can be done for acceptor atoms as well. In this particular case, we want to select aromatic carbon and click Apply and OK. We can now see that there are some hanging lines and atoms coming from certain hydrogens of the benzene ligand. You'll note that the picking mode is set to expand contact by default, and simply clicking on each of these will reveal neighbouring molecules that are joined by those intermolecular interactions. We can see in this structure that it is in fact leading to this layered arrangement with interactions between those layers. You can turn off the H-bond display here and turn it back on as you desire. You can also tidy up the display by going to Contacts, then Build Network, and delete those hanging bonds. That leaves you with a much cleaner picture. You can easily reset the display from the Reset button in the Display Options area. This returns us to the single molecule view. You might also want to take some measurements. For example, you might be interested in the lengths of the carbonyl-carbon to cobalt bonds. To do that, you select the appropriate picking mode from the drop-down menu at the top. In this case, we would choose Measure Distances and then click on the desired pair of atoms. Such measurements can be between any objects. They do not have to be bonded. You can also change the label size by right-clicking, going to Labels, Label Size, and increasing that to a suitable number. 20 is appropriate in this instance. You can of course measure angles and torsions as well by selecting those from this drop-down menu. For instance, we could measure the angle between the oxygen, carbon and cobalt and see that this bond is nearly linear. Lastly, we can explore how to make high-quality images from the currently displayed structure. To do this, you go to File and Pauvre Image. You can see at the top that you can set the size of the picture in pixels. You can select the materials properties. For example, you could have a metallic finish or any of these options. You can also choose the background color, and you can generate animation frames which can be joined together by other software to create a video. You can preview the output, then select a suitable output directory and render the image. This creates a high-quality image, as can be seen here. This concludes a demonstration of the basics of Mercury. For more resources on how to use Mercury, check out the links in the description and the playlist at the end of this video. Thank you for watching, and don't forget to subscribe to our YouTube channel.